Hello and welcome back to our language design activity. We're using the OM Language Library to iteratively design and prototype a little programming language. The thing we need to do right now is add arrays, maps, sets, and maybe even optionals to our little language, which so far has functions, a few statements here and there, if statements, while statements. It has functions, it has function calls, but the only primitive expressions we have right now are strings, floats, ints, the Booleans true and false, function calls, identifiers, which can be used as expressions, and parenthesized expressions. And we only have these basic types right here. So we should begin with let's begin with arrays. Arrays are a good place to start. I think I would like to have something like, if we were to print in square brackets an array like 1, 2, 3, 4 might be good. We should also be able to declare variables. So let X be of type array of integer. Let's do an array of Booleans, and we'll make it be, say, false, true, and true, just for a little bit of variety. Of course, right now this does not pass because we don't know what this square bracket is. So we're currently working on expressions which are array literal. So let's begin with that. So out of the many expressions that we can have, we're going to have a new kind, an array literal, which is going to be in brackets, a bunch of expressions separated with commas. Now we know how to do that. In OM, we do list of, so list of expressions separated by commas. And there we go. It does not pass right now because we don't know what the square bracket looks like for a type. But we actually got past this part, which is nice. We actually have an expression right now, which is an array literal. And where is that? Where did that go? It's right here, an array literal. We can clean things up a little bit right here if we need to. Okay, let's work on getting a type. So out of the many types we can have, one type that we're adding right now, in addition to ints, floats, booleans, and strings, is the array type. So that's just a type inside of square brackets. Let's clean that up and let's deal with the usual problem with the arity and call this an array type. And it's all greened up, which is a good thing. And it looks like, therefore, we now have arrays in our language. Okay, and that is nice. We have both array types with are just things like this, and we have array expressions like so. All right, next step will be, let's do maps next. So let's see, what might that look like? It might look like something like this. Maybe we'll print something like, California going to Sacramento and Alaska going to Juneau. Let's just start this way. Let's make a little map. So a map is going to have in it a set of bindings separated by commas, delimited on the outsides with curly braces. Doesn't sound too bad. Let's jump right into expressions. And right down here, we'll go with the curly brace and a list of, we'll call them bindings. And we'll separate these with commas. We'll end them with curlies. This will be a maplet or a dictionary literal. Call it maps or dictionaries. I don't really think it matters. Dictionary literal. We need to define a binding. And a binding is just going to be an expression separated, two expressions separated with one of those. And there we go. This is, it's green. It's green, yay. How nice. Okay. We might want to also have variables whose type is a map from one type to another. That may be something like this. We'll say, let M be What should we do? I know Swift likes to say, dictionary into something like this, right? Equals, and then, maybe an empty map over here. But rather than that, let's go with Swift's abbreviation, which is kind of nice. That just uses these square brackets. So how about this? We'll let M be a variable. Its type will be dictionary, mapping integers to Booleans. We'll start it off with an empty map right now. I'm good with that. Yeah, this test fails because we don't understand that particular type. We do understand the map literal, we just don't understand the type. So let's go down to where types are, and we'll bring in a dictionary type, which is one of these, a type, a colon, and another type. And this gives us the dictionary type. Dictionary type and green. That's good. And we can even have a 3 maps to false. It would be an example. Make sure that's good. All right, nice. Next one, let's do optionals. So let's see how optionals might work. I might like to have something like, hey, my boss will be an optional string. And optional string. Okay, so can I just put a string here? I mean, is there this idea of actually converting strings directly to optionals? I'm not sure I like that. I like what a lot of like Haskell will say, if you take a string and you want to wrap it into a optional string, you can use just. I kind of like the word sum a little bit better. And then if I had decided not to have a boss anymore, then I would assign it to, well, can we just say nil? I mean, I don't really like just saying nil, because when I look at nil, I don't know its type. I need to know that it's an empty optional for something. So I prefer saying things like no string. This is just the way I like to do optionals, because, and you know what, we're designing a programming language here, so this is the way it's going to be. So we're going to use sum to wrap an object into an optional, and we're going to use no followed by a type as a way to say that this optional is empty. So a couple of things I need right here. First of all, we need to define the optional string type. And so in addition to the types we have here, any type followed by a question mark will be an optional type. Now you can probably see there's going to be a problem right here, right? Because when I look at this code right here, I still have the same problem I had before. It doesn't like this question mark right here. Again, Ohm tries things one at a time from left to right or from top to bottom. Once it sees string, it's found its type and it's good to go. It ain't going to look any farther. It's not going to look for that question mark there. So I mean, I think we're in a position where we need to make sure, again, put the complicated thing first. Okay. So we'll put that optional first. We've got to get rid of this thing because that's no longer needed. And when we look down here, yeah, we're fine until we get to this sum. I mean, it really doesn't like this sum over here. So let's create sum and no as new keywords. Sum sign, what the heck? Sum is going to be the word sum. Again, not followed by an alphanumeric, and the word no is going to be the word no, so followed by an alphanumeric. So those are our keywords. Have we been pretty good about remembering our keywords down here to not be identifiers? Looks like we have not been. So I'm going to take care of that right now. Should probably spend some time cleaning up. I mean, ideally we'd be working with pretty or something like that, but unfortunately, no. How are we doing now? Looks like it doesn't like some because these have to be expressions right now. So new kinds of expressions, we need sum followed by an expression. That's going to be the way we wrap something into an optional. So that'll be a wrapped object. And then we'll say no followed by a type. And that will give us an empty optional. So empty optional, perhaps. Are we green or are we green? Yeah, we are green. That's pretty cool. And, in doing this no type right here, it kind of reminds me about having to deal, say, with the empty array, because I'm thinking, what if I tried to print something like this? Well, this is actually okay and it passes. And I don't know, part of me says, yeah, I guess that's okay. But what if I said something like, let X be, an array of something. And then let's say later I wanted to add in something into this array. I wanted to add in a new value. Like what value do I add in now? I mean, is this an array of integers? I mean, should that be allowed? Should this be allowed? Like what should this be right here? An array of what? It's like when I have empty arrays, it's like I want to be able to say like what the type of that empty array is. So just like with optionals, we said something like no string, so we didn't have to say just nil. I mean, maybe we should say that this is a empty array of something, right? Maybe it's an empty array of Booleans, or it's an empty array of strings. And this I kind of think is, sort of important, that I would like to in here say, and I'm going to put this here, and then I'm going to put this here. And then maybe in parentheses, I'll put the word of followed by a type. And this helps me know that I actually have an empty array. And might as well, why let people put in spaces? Probably no need. All right, so let's say we have an empty array right here. Looks like of is going to be a bit of a problem. So let's put in of, and it will just be the word of, alphanumeric. It's a new keyword. And then we'll say let should be of type string array, and it'll be an empty array of string. So, I mean, right now, this still works, but we really don't want that to work, right? I mean, I kind of want it to look more like this. This leads me to believe our language pretty desperately needs type inference. I mean, look at the way we're repeating these types. But so be it for now. Let's leave it here. I want to make sure that I want this to work, but I think I do not want this by itself to work. So let's put it down on this thing, because I don't want that to work. And there's a cool thing you can do in Ohm if that's ever needed. So just like we say a list of expressions in here, we can make this be a non-empty list of that. And now everything is green, everything greened up right now, because I'm saying that, okay, if you're going to put things in square brackets, you should have at least one thing there. If you're going to put something in square brackets, that way, like, we'll sort of know what the type is, because if it's empty, we really can't tell the type. We won't really be able to infer that type. I think a similar thing should happen with our dictionaries, right? So if I ever had so we should probably make this a non-empty list of bindings for our dictionaries. And if you want to have an empty dictionary, we should find a way to write that, which is a little bit kind of consistent with the way that we're doing our dictionary and our optional, with our arrays and our dictionary literal. So that might take a form of saying, maybe we can do that of business again. So something like bracket, and then maybe of, and then we'll need a type. But actually, but I think what we want to have, and let's put this in as print, maybe this of what? Well, over here, I think we need to say what the two types are. So should that be something like int comma bool, empty array of int bool, or empty array of int arrow bool, or empty array of int colon bool? I actually kind of like that. So type colon type. And this lets us know that the empty dictionary is sensible. And up, it almost works. What's wrong here? Paren, paren. Did I do something wrong? Brace, brace. Yes, my test is wrong here. That should be a parenthesis. It's still not right. Brace, brace, paren of type colon type. Semicolon, it wasn't even wrong with it. That part wasn't wrong. The part that was wrong was the actual statement. Okay, we have dictionaries, we have arrays, and we have optionals. And we are to the point where our language, other than, cleaning this stuff up right here, is fairly decent. And we could do a few things. I mean, I think we're missing arrow functions. We're missing some fancy escapes inside of our string literals, right? Because right now our string literals can't contain new lines, for example. Although we probably could just throw that in right now. I want to see how to throw in a backslash into your, backslash n into there. We can say, let's say print, and we'll say hello backslash n world, right? Like right now, if we had something like this, how does that work? I mean, when I take a look at the string literal, it's just a bunch of characters right here, right? Look at this is a backslash character. This is an end character. I mean, I think I would like the backslash and the end to go together and just be a new line. And that's actually doable in Ohm. We can say that the character that we place in our string, one of the things we could have is we could have a backslash followed by an n. That could be one of our characters. Otherwise, we have one of these. And then this backslash n right here is going to be, there it is. See, look at that. The backslash n all by itself. That is a new line escape. So might as well mark it as such, just for fun. We can say like a new line escape. And this one over here is just like a regular character. And now we have this nice little feature here where we have a new line escape, which is kind of nice and clean. Now, what else would our language need? Oh, I don't know, modules, promises, arrow functions, classes, objects. Like right now, this is not a functional language, right? Our functions are not first-class values. Our functions always have to be named. And well, I mean, maybe we have a long way to go, but we're at a good start. So I think it's a good time to stop this episode now, and I will see you in the next one. Bye.